really interesting kind of stuff coming up here. So this is really a profile of what we're looking at for the unhealthy IO. It's split, it's small, it's random. And this is really not what we want. As great as virtualization has been for server efficiency and for bringing the VDI space in, one of the biggest downsides to virtualization is that it really has added a lot of complexity to the data path. And this is what the IO stream ends up looking like. So there are two severe IO inefficiencies contributing to this. The first one is kind of what we've been pounding on for the first half of the webinar, is what we refer to as the Windows IO tax. It really is Windows creating this IO characteristic that's much smaller, more fractured and random than it needs to be. And it's kind of the perfect trifecta for bad storage performance. It's this death by 1,000 cuts scenario kind of eating away at the environment. Again, as we covered, what can you do about it? Throw more hardware at it, optimize the image, which we all know really can't be done. You're not going to go rewrite code, and you've already got all the applications in there because you think you need them. So the only other thing in the image left to optimize is the Windows OS. And we do a lot of the over provisioning, all the excess IOPS we talked about earlier, focusing on IO response time, which are two of the fallacies. We can actually get a lot more out of this Maserati that we put in there. Now, the other thing that we want to look at is called the IO blunder effect. This is that second IO penalty, also AKA IO contention. We all know what this is. It means that the workload from VDI client number 1 or server number 1 is being impacted by the workload from client or server number 37. Whether they're related or not, they are sharing the same hardware. And even if they're not on the same host, they're sharing the same backend storage. And that can be really tough. One of our most common use cases is SQL. I'll give you a real quick example of SQL. We did a proof of concept very recently on an environment that was 6 hosts with 120 SQL servers, and they deployed to one server. It looked just like this, and it was that they were missing an SLA with that client every month, and it was costing them a lot of money every month and a penalty back to the billing on that client. And we told them it's not going to work. We're 99% sure it won't work because of the IO blunder effect. So they did it anyway. The next month, it didn't work. The next month, we begged them, please give us as many of your heaviest IO servers in this cluster as you can. They gave us 10. They made the SLA by 3 minutes for the first time in over a year. The next month, the software was removed, and they missed the SLA by 5 minutes. And then the 4th month, they put us on 119 of 120 servers, and they made the SLA by 17 minutes. It was phenomenal. So we also were able to verify in their change control process that velocity was the only change being made. The reason I bring this example up is because it is a textbook classic case of the IO blunder effect getting in the way. So like I said, as great as virtualization has been for efficiency and cost savings, it really does add a lot of complexity to the data path, and it adds latency as well. And this is what healthy IO should look like. We get this optimum IO profile. We get contiguous large sequential IO. And this is what's going to give us that 30 to 40% improvement in throughput of the overall body of data. So let's take a look at how velocity does this and what it looks like.